Hello, API Days Australia. I'm Tim Pettersen, Head of Developer Experience for Atlassian, and I'm also known as Cannon Boy on various forms of social media. My topic today is when APIs aren't enough, why SaaS leaders are investing in integration platforms as a service. First up, a little bit about me. I've been at Atlassian for 17 years, and the last 10 or so I've been working in and around Atlassian's ecosystem. Before shifting into developer experience, I led the development of Atlassian Forge, our new hosted API platform, which I'll be talking a little bit about today. Before that, I led our strategic integration teams, building Atlassian apps that consumed APIs from a range of other SaaS leaders like Google, Salesforce, Microsoft, and Slack. When I'm not writing software, I also enjoy speaking and meeting like-minded technical folks in the community. So I'm very excited and honored to be here. Please come and find me if you'd like to chat more about platforms, Atlassian, or APIs. So you may have heard of Atlassian, or you may have used one of our many products, including Bamboo, Bitbucket, Trello, Fisheye, Compass, and 101 flavors of Jira. But you may not be aware that on top of these products, there are a set of APIs. And on top of those APIs, there are tens of thousands of tools, integrations, and mini products that have been built by our fabulous developer ecosystem. So first up, I'm going to give you a little demo of an AI-powered app that was recently listed on our marketplace, so you can have a bit of a feel for what Atlassian apps can do. This particular app is called Released, and it's designed to make publishing release notes easy peasy. Now, what you can see on the screen here is actually just a Jira board, part of the Atlassian core product experience. And I've got here a set of stories that are scheduled for the upcoming 1.1 release of a fictional mobile app. Now, you can see I've been a bit lazy and neglected to add any details to the tickets other than a brief user story, which is shortly going to become a problem because we've got to write some release notes to let customers know what changed. Enter AI release notes. So this little app, which we are now in the user experience of, allows us to select a fixed flow version in Jira. And from this, it will generate a release note template where we just enter a title, and then we can pick a section of stories from our upcoming release, and then press the attractive AI generation button, and it will go and generate some copy that we can then use to communicate to our customers about the release notes. And from here, we can publish this to a website or export that to Confluence. Now, what's cool about this is not so much that this is a nifty product feature, but that other than the Jira board we saw at the start, that entire user experience was built by another Australian company named Release Software and shipped via the Atlassian marketplace, where it's making revenue for them and us, and delighting our mutual customers without us having to commit any R&D resources to it. Such is the awesome power of APIs. Now, our ecosystem and the people in it are super important to Atlassian for three big reasons. The first is that we have a large commercial marketplace. So there are hundreds of independent partners, just like Released, selling apps to our customers. And this is an important revenue stream for Atlassian. We just passed $3 billion in lifetime sales, purely off the back of these APIs. The second is that strategic partnerships is crucial to Atlassian product strategy. While our own corporate DNA is focused on team collaboration, over the last few years, we've launched strategic integrations with DevOps partners, security firms, chat tools, CRMs, and all sorts of other SaaS businesses. Again, all built on our APIs. In some cases, we've also acquired partners who've built particularly strong integrations with us. So a lot of our corporate development is also powered by our APIs. And finally, we have tons of Atlassian customers using APIs themselves to automate and improve their own workflows and productivity. And we actually see a strong correlation between customer API usage and long-term customer retention. So we believe APIs help us maintain core product revenue by having stickier customers. However, we realized a few years ago that awesome as our ecosystem is, it's not quite as successful as it could be. And we came to this recognition because we're at a bit of an interesting period in Atlassian's history. Today, in October 2023, We have 3 supported deployment models for our software: cloud, server, and data center. But on February 15th next year, we'll officially be ending support for some of our server products. And all of our remaining server customers will need to make the choice to migrate to one of our cloud offerings or to data center if they want to continue self-hosting. But for most customers, we are strongly recommending that they migrate to the cloud. However, we noticed that apps play an interesting role in the decision process that customers make. Some customers were dropping certain apps during their migration to cloud. Some other customers were shifting to data center instead of cloud because of differences between cloud and data center apps. And some server app developers weren't rebuilding their apps in cloud at all, even when there was customer demand for it. And we realized that this customer and developer behavior was driven by large differences in how our APIs work in our cloud and data center products. So we started on a journey to overcome those differences and make cloud more appealing to developers to build apps for our cloud products, and simultaneously make cloud apps more appealing to our customers. But first, let's look at how our platforms differ. Now, our first cloud platform was called Atlassian Connect. Like most SaaS platforms, Connect was built on top of various client-server technologies used to communicate over the web. An app developer deploys a web app that consumes RESTful APIs and webhooks served by our products. And then they can render a user experience in an iframe embedded in our product. So that release notes app we just looked at was actually an iframe experience that had been decorated to look just like the Jira host product. App developers then host this web application under a domain that they own and register it on the Atlassian marketplace. And at that point, they're responsible for all architectural, operational, and security concerns relating to that app. Now, this is quite different to how it works on server. In our server products, apps are Java bundles deployed into individual customer sites, and they're managed by customers' in-house IT teams, which means there's a very low operational burden for most server app developers. And server apps only need to scale to the single customer site that they're installed into. Server apps can also extend the user experience of our products, but instead of an iframe, we have a set of view technologies that abstract away authorization and authentication and security concerns like XSS and XSRF, which makes it a lot simpler to build and secure app experiences on server. And beyond just UI helpers, we have a ton of powerful abstractions on server for persistence and logging and profiling, task scheduling, backups and schema migrations. Basically, everything that we've built internally that help us build our own products, we've tried to externalize to server developers to make it easy to build apps. And these differences all boil down to a dramatically different developer experience for building apps for our cloud and server products. In cloud, developers have to architect and maintain high-scale, resilient, secure, and compliant web applications that meet the demands of Atlassian's customers. In server, you could write a few Java classes and front-end assets, and the platform would handle basically everything else for you, letting you focus almost entirely on business logic and building awesome user experiences. And this delta in developer experience meant that for some, the cloud was just too complex or too costly or too hard to be worth migrating their apps. So while our cloud ecosystem is wildly successful, and we have thousands of apps and healthy revenue and growth, if we were a SaaS-only business, we probably wouldn't even know that there was anything wrong with it. But because we started with on-premise software, we could observe that we were leaving some developers behind on server. And we hypothesized that our cloud ecosystem could be even more awesome if we could somehow lower the barrier to entry for developers in cloud. And we're also a little bit worried about the future. While building cloud apps is complicated today, it's only becoming more complex as customers everywhere continue to raise their expectations for user experience, performance, security, compliance, and data privacy. And this is not just a concern for Atlassian's ecosystem. API consumers built for any SaaS product typically operate on the data hosted by that product, which means protecting customer data is always a shared responsibility between SaaS products and their ecosystems. So we decided to reinvent our cloud platform to make it easier for developers to build apps and also make it easier for customers to trust those apps. We started exploring different ways that API providers can shoulder more of the complexity of app development. And we noticed Atlassian had been heavily investing in the trust posture of our own cloud products. And we thought, what if we could go well beyond just APIs and share Atlassian's cloud infrastructure directly with our ecosystem? So we decided that a hosted ecosystem platform was worth evaluating. But what sort of hosted platform? There are a range of different options. Atlassian has a strong technology partnership with AWS, so we first considered hosting managed AWS accounts and allowing ecosystem partners to deploy directly into them. We also considered a platform as a service model, or a PaaS, as a slightly higher level of abstraction. Under this model, partners would package a web application in a prescribed format, probably Docker containers, and then we'd run those containers for them in our cloud. And finally, we evaluated a functions as a service platform, also known as a FaaS. This meant instead of web applications, developers would deploy a function or a bundle of functions which compose their app. Now, each of these options provides different levels of abstraction, with a PaaS and a FaaS shifting more of the complexity burden onto us as the platform, but at the cost of some flexibility in how developers can architect apps. Ultimately, we decided on a FaaS model. This allows us to show more of the complexities of app development and provide the strongest platform guarantees to our customers. And we decided to call this new platform Atlassian Forge. In fact, Forge is actually closer to an IPaaS, or a specialized app FaaS, because we go well beyond what a typical FaaS like Lambda or Google Cloud Functions does, because we bake in a bunch of abstractions that simplify app development. And we'll take a closer look at those in a moment. But before we do, I want to point out that Atlassian's journey here isn't unique. Forge is in part inspired by some other hosted app platforms like Google AppScript and Salesforce's Apex platform, and other SaaS companies are launching similar offerings all the time. Like Forge, AppScript in particular has a strong focus on security and data privacy, which makes sense. If you're going to install apps from third parties into your Gmail account, you're going to want a platform that has some strong trust guarantees. So once we'd settled on a FaaS, our first step was abstracting away as much infrastructure and app operational concern as we could. With our original cloud platform, Atlassian Connect, building an app that could scale to tens of thousands of customers and potentially millions of end users became a challenging cloud architecture problem. A typical enterprise-grade app would be composed of load balancers, microservices, scalable worker pools, and various hosted database offerings, plus all of the usual observability, monitoring, and orchestration that you need to keep web services running. Developers were essentially building high-scale web applications. With Forge, we wanted a dramatically simpler developer experience, something a bit closer to what we had on server. We want a dev to be able to write a simple function, deploy it into our cloud, and have the platform handling scaling concerns automatically. So we chose Amazon Lambda for this purpose, and it works great. We can easily deploy functions that scale up to meet customer demand and scale to 0 when they're not being used, which makes Forge very cost-effective to operate. Now, a Forge function is written in JavaScript and has a simple YAML declaration, which defines which part of the Atlassian product you're extending. This is an example of a Jira trigger function bound to issue creation and updated events. So this is a bit like a webhook, except the event payload is passed to the trigger.js function on the right-hand side there, rather than being sent over the web. Once deployed, the platform handles all of the wiring, orchestration, and execution concerns for you. The code on this slide is actually a complete Forge app that you could deploy and install into your Jira site today, and it would start happily logging issues for you. We have a variety of function types that developers can deploy. Triggers like this one can listen for product events, or you can run functions on a schedule and make use of our APIs to build out your functionality, or they can ingest webhooks from third-party systems, or serve as the backend for an app user experience, like the one that I demoed earlier. Now, this simplicity of our FAS primitives is the root of a great developer experience. You can write a Forge app from scratch in a few minutes, or use a simple starter template that can be deployed and running in seconds. There's no infrastructure management because we're running everything for the developer. This also simplifies ops. We generate logs and metrics automatically and expose them via a web-based developer console. And this simplicity also mitigates most web application security risks. These functions are ephemeral. They aren't sitting on the public internet, and they don't serve HTTP requests directly, so they're very difficult to attack. And because they run on Atlassian's infrastructure, we can also monitor and scan client code when it's deployed, much more effectively than with traditional client-server apps, where the client is a bit of a black box. We're also working on deploying these functions into every region that Atlassian has customers, and also making our attached storage APIs automatically respect the data residency requirements from customers to minimize the efforts that our ecosystem developers need to put into compliance. There are some downsides though. Serverless functions are a very opinionated way to architect software, and it is difficult to solve some business problems using them. For example, it's not going to be possible to run AI models natively on Forge anytime soon. It's also challenging to retrofit serverless onto an existing web apps architecture, which does complicate the migration journey for a lot of our existing partners. To overcome these problems, we're continuing to invest in remote capabilities to allow Forge apps to gracefully communicate with external APIs or with legacy Atlassian Connect services as needed to give developers a bit more flexibility. The other drawback is that building a FAS is a heavy R&D investment. Though AWS does a lot of the heavy lifting in terms of deployment and runtime, we've had to build a complex set of compute and storage primitives on top of Lambda, DynamoDB, and SQS that requires quite a high upkeep from us. But we believe this platform investment is worthwhile, as it lets our partners focus on building awesome user experiences for our customers. One aspect that Lambda doesn't provide out of the box is network isolation. Our customers wanted a strong security and data privacy story for apps, so we wanted to ensure that Forge functions could interact with product APIs and Atlassian services, but restrict how data is shared with the public internet. To do this, we locked down the Amazon VPC that Forge functions are deployed into and created a proxy that manages all outbound connections from Forge apps. Forge app developers then declare which domains and URL patterns their apps need to make requests to in their app manifest. This list is displayed to customers when they install the app to provide additional transparency into where their data is going. Or, if no domains are specified, the customer can rest assured that their data does not leave the Atlassian cloud. Now, this was a significant technical undertaking, but it does allow us to tell a really strong privacy story to our customers on behalf of our developers in our ecosystem. Another area that we wanted to abstract and simplify was authentication and authorization. Prior to Forge, authentication was pretty difficult to consistently implement correctly. This was partly because Atlassian Connect, our prior platform, has been around for almost a decade, and unfortunately suffers from a somewhat incremental design as we keep layering new features and security controls on top of it in response to possible threats. To illustrate this, I'm going to walk through Connect's auth protocols quickly to give you a bit of a feel for the developer experience so you can see what we're trying to solve for here. Atlassian Connect uses a symmetric secret for authenticating requests between Jira and its apps. To limit the blast radius of a secret being exposed, we actually issue separate secrets for each customer site your app is installed into. These secrets are issued via a webhook on installation, and that webhook is also signed to prevent spoofing, so you have to verify it. This means that even if your app would otherwise be stateless, you have to have a database just to manage secrets, and also have to be able to rotate those secrets on demand. That secret is then used to sign outbound requests to Jira using a custom authentication scheme, which I helped design and now deeply regret, and also used to verify inbound requests from Jira. We also have a separate auth protocol to allow apps to impersonate users when needed for certain use cases. This flow is handled by a different scope, and a completely different auth flow that requires you swapping your shared secret for a short-lived bearer token that you typically also want to cache somewhere. So yeah, authentication under our old platform is complicated and hard to consistently get right, which makes it both a pain for the developer experience and a breeding ground for security bugs. Fortunately, in Forge, we've almost completely abstracted away authentication. Here's another trigger function, again, a complete function that you could copy off this slide and deploy if you wanted to, that listens to issue events and posts a comment on any newly created issues. Now note the conspicuous lack of secrets, headers, HMACs, OAuth, or anything else authentication related. We don't have to authenticate the webhook event or the outbound request to Jira. Because the function sits within our platform, we can handle all of that authentication under the covers. You'll notice here we also have a helper method for impersonating the app's context user. It's currently authenticating as the app's bot user, but if we switch as app out for as user, it will automatically infer the current user from the context and authenticate with the API using that user instead. Note that we also don't even have to specify which Jira site we're making a request to. The function also infers it from the context. So we've gone from complicated authentication to fully abstracted auth in one fell swoop. And having a FAS model allows us to build all sorts of nice little developer experiences like this. Now, unfortunately, I'm out of time. There's a ton of other aspects of Forge we could dive into. We have a declarative UI kit that enhances security and simplifies UX development. We have a new way of hosting secure iframes and a set of neat developer tools to make it quick and easy to develop slick apps. But if you're an API practitioner, I bet you're wondering whether a hosted ecosystem platform is desirable and practical for your business. Now, I'd say that going from REST APIs, iframes, and webhooks to a fully hosted cloud platform has been a huge learning journey for Atlassian. There isn't a lot of prior art to work from or off-the-shelf technology that you can use to build this kind of thing. We've had to heavily invest in our ecosystem team and solve some gnarly technology problems to build a platform that meets our privacy and developer experience goals. But we are seeing some major successes, both in terms of customer demand for Forge apps, particularly from enterprises and other regulated customers, and also some incredible developer success stories. One of the awesome things about a hosted platform is that we have amazing analytics. We can see exactly when an app was created, when it was deployed, when it was updated. And a recent analysis showed that 82% of Forge apps on the marketplace launched within 3 months of the developer first creating their app. And almost half launched within 4 weeks. We believe our bet on a hosted ecosystem platform is paying off. Last month, another brand new commercial partner wrote a great blog about how they went from no Atlassian API experience at all to launching a Forge app on our marketplace in 2 months. If you're interested in reading that case study, you can find it at go.atlassian.com/onward, or I'd be thrilled if you gave Forge a try. It's completely free to anyone with an Atlassian account. And if you don't have one of those, you can sign up and get free developer versions of our products at go.atlassian.com/forge. Thank you very much. That's the end of my presentation. Feel free to reach out on social media. I'm at Cannonboy, or if you're attending API Days Australia, come and grab me for a chat. Thank you very much.